Hi, welcome back to the last topic on the connectivity of the internet, artificial intelligence of things. So this is part 4. So first of all, I want to just talk about the summary again of the different internet protocols. As mentioned in the last video, there are different wireless networks actually available. Therefore, we do actually find different protocols being defined to work over these different environments. So we have MQTT, MQTT-SN, which I have mentioned for the new version of MQTT version 5. This actually merged into the same standard, but the common implementation still have both of these as uh, separate standards. Then we have CoAP, and then we have AMQP. Then we have another one called Stomp, and lastly we have which we're going to spend a little bit more time about this particular video, which is using the web stack, which is the HTTP protocol that has already been made very widely used by the World Wide Web. So we are going to, just like the XMPP, try to reuse the experience they've gained with the web stack for the Internet of Things. So I want to just clarify a little bit about the AMQP protocol. Now, the AMQP protocol is a message-oriented protocol, so it can be implemented in two ways. One is actually really peer-to-peer or point-to-point communication. So you can see from the earlier slides that some of the slides actually refer to AMQP being used in strictly from one sender, one receiver context. So it's a direct connection between the two via the broker. So the broker basically just gives you a one single direct connection. However, this is not the only way that AMQP can work. The broker that you have in AMQP can also support the topic-based publish and subscribe kind of mechanism, which I mentioned earlier, which we also find in MQTT. So AMQP gives you some flexibility in what you want to implement or the mode of communication that you want to implement. Right, so here the same thing that is noted here. So for in broadcasting, that means you want to send from point to multi-point, you can support it with MQTT using the broker. It's indirect because it has to go through the broker, and then the broker will actually send it out to various receivers. And in this case, if we are referencing a direct connection for the AMQP, then there is no broadcasting because it's basically one receiver, one sender, or one sender, one receiver. However, if we can actually configure the AMQP broker to actually support, and many of the implementations of AMQP that's commercially available actually support this kind of feature where broadcasting is actually possible. Although in the standard, it doesn't constrain you to actually only have broadcasting and nothing else. So you can have no broadcasting and have a direct so a direct exchange between the sender and the receiver. So I hope that clarifies that. Okay, so that's why you will see both descriptions for AMQP, whereas for MQTT, it's quite straightforward. The standard basically refers to a publish subscribe model, so that's commonly implemented. So here's the AMQP. So the RabbitMQ is a very common, very popular message broker implementation. So it does support AMQP. So here you can see that the information that's being produced will be sent to the front receiving end called the exchange. And in the AMQP broker, there will be multiple queues. So in the case of a direct exchange, the message will be just forwarded to one single queue and then finally to the consumer. So it is effectively like a direct communication between the producer and consumer, no broadcasting. However, you can configure the exchange to have more than one binding. That means the information that's sent to the exchange, it will be copied out to two queues instead of just one queue, in which case broadcasting can be supported with the AMQP protocol as well. So just to repeat, this is not strict. This case of not supporting broadcasting is only if you implement it as such in the broker. So you can actually support it if you implement the broker like the one that is actually in the Rabbit MQ. You can support topic-based exchanges. So you can see that first the sender sends it into the topic exchange here. And this topic exchange then actually duplicates the message into two other receivers that have subscribed or consumers that have subscribed for that queue. So each of this is the queue, one queue for all error, one queue for all logs, and one queue for all success. But the topic that's related to log success is actually two queues, whereas the topic that's related to log error is actually two other queues, the top two. So you can actually have this same broadcasting mechanism that you find in the MQTT being implemented with AMQP as well, right? Just that the standard that is being defined or the specification allows for different modes of exchanges. Hence, sometimes it does cause a bit of confusion, and that's why I also wanted to just explain that over here. So let's move on to the next part, which is actually a key focus for this last video, which is the Web of Things. Reusing the experience that we have with the web stack and using that HTTP stack for connecting an Internet of Things via the web protocols. So by definition, the Web of Things is actually defined by the W3C consortium or the Worldwide Web Consortium for solving interoperability issues. As you mentioned earlier, there's a whole multitude of different protocols for the Internet of Things, and it's very burdensome for organizations to support so many different implementations within organizations. So interoperability would be much more enhanced, just like for the World Wide Web, one protocol to rule them all, right? Rather than having many separate kingdoms, one single protocol to rule them all, which is the web-based protocol. So we are going to try to use the standards that have been defined for the web to solve all these interoperability issues for the different Internet of Things platforms and applications. The other definition that we also find is that the Web of Things seeks to counter the fragmentation of IoT by using and extending existing standardized web technologies, and by providing standardized metadata and other reusable technological building blocks. The W3C, the World Wide Web Consortium Web of Things, or WOT, enables the easy integration across IoT platforms and application domains. So one single protocol to rule them all. So we can see here a comparison between the standard, well, Web of Things actually relies on this thing called WebSocket, which is an enhancement of to the standard way that the HTTP protocol works in a standard web browser. So in the standard web browser, it's very much a request response protocol. So the HTTP application protocol allows us, the user or the browser, to send a request for a particular URL. And the server, or the web server in this case, will then basically look at the URL and pick out the corresponding data that corresponds to this URL. And if it can successfully find that resource or data that's linked to that particular URL, it will then respond with OK, and then also send back the data. So once the data is received by the receiving web browser, it will then basically try to render or display the web page that's being written, or the information that's being written. Now, if the information is in a HTML format and it has pictures inside, each of the pictures does require the browser to send a separate request to actually retrieve just that particular image. So one single web page may have multiple requests, okay, one for the main page, and then separate requests for each of the JavaScript, CSS, images or videos that you have inside there. But the interaction between the two is basically a request and a response, and then another request. Now, you can see here in lies one of the problems with the protocol. It is very asymmetric, right? The information is basically the request is coming from the client, and then the bulk of the information is basically sent from the server back to the sender, right, of the request. But how does the sender send information to the server. It can only do so in the request, and typically the request is actually much smaller. So it's a bit asymmetric, and one single page, as I mentioned before, already requires so many requests. So there's a bit of overhead in this handshake that's necessary because of this request response interaction. So the WebSockets actually was added on later as a common mechanism for us to allow a more symmetric two-way or bidirectional exchange of information by reusing that HTTP connection and repurpose it for this simple connection to occur. So what happens is that actually the WebSocket request still takes advantage of the HTTP protocols, the normal HTTP request, and the response coming back will basically switch mode for this connection. So the request comes in as a HTTP, but when it is successful, I'm going to change that connection, the TCP connection that I create, into a WebSocket connection. So then after that, I can actually use that connection for whatever protocol I want to run within. It's actually transparent. So it just opens up a pipe between the 2 points, and I can send anything in both directions for this particular pipe. So previously, the pipe only allows me to send requests from one end and then a response from the other end. But once I've actually switched that connection into a WebSocket mode, you can see that I can send multiple 3 packets of data from the server without waiting for any response, any request from the client. And then finally, after I receive these 3 packets of information, the client actually just sends back 1 single packet, and then after that, another 2 coming back from. So it's actually, once it switches mode into a WebSocket mode, it just opens up a transparent pipe. And you can send information in any sort of manner that you have predefined between the client and the server. You do not need to stick to the HTTP style of interaction anymore. So this actually allows us to use it in a more flexible manner. And you can see that for the Internet of Things, the handshake that you use using the web protocol, once you have opened up the channel or the bi-directional communication channel between the two, as in the form of a WebSocket, you can then just use that to exchange information either from the sender to the server or from the server back to the sender. And you do not need the lockstep request and response anymore. Once you're done, finally, the one that actually accepted the WebSocket connection will just force it to close, saying that, hey, actually this exchange is over, goodbye, and then close the connection. Now, if you need the connection again, you need to make a new request to actually create a new WebSocket connection. Okay, so you will see that the Web of Things would make use of HTTP for some of the interactions, but it does actually use the WebSocket as well to enhance the communication, especially for supporting things like publish and subscribe. So here's just a comparison between using the REST style, which is the request response style, versus message-oriented protocol like the MQTT. So in the MQTT protocol, there's always a broker, like a postman. So the publisher of information, the sender will send the information to the postman, the broker, and then that broker will basically send that corresponding information or message to all the subscribers who have said that they are interested in this particular type of message. So this is like sending a letter. So if you send the letter to the postman and then the post office, and then the post office is basically in charge of getting it to the final destination who have subscribed or who have indicated interest for that particular message. It is a message-oriented approach, MOM, message-oriented middleware, because it's like sending a letter. But when we come to the HTTP protocol and the TCP, it is really not so much a message-oriented interaction. It is what we call a connection-oriented implementation. So just like making a telephone call, once you have made a telephone connection to your destination party, both of you can just exchange information freely. You don't have to sort of separate out your conversations into distinct letters or packets of information. So this is what we call a connection-oriented mechanism. Right, so For the HTTP protocol, TCP, which forms the connection, it forms that type, but the HTTP protocol is constrained to only send a response to every request that you send from the sender. So the sender here, in this case, the client will send a request and then the response will come back from the other side. Always in this lockstep manner. But it doesn't need to keep reopening the connection once it's been finished. So for the modern HTTP1 protocol, it can actually continue that conversation. Once that connection is set up and then you keep using the same connection, you reuse the same connection until you actually want to end the interaction. Then you close that connection. Now, but it doesn't allow you to freely exchange the information without this request response interaction, unlike the WebSocket. Hence what I mentioned just now. For the WebSocket, there's an enhancement that allows you to switch mode for this connection, so that after the connection is switch mode to the WebSocket mode, you can just freely exchange information after that. So here we can see how the Web of Things is used in a scenario where we have clients like your mobile phone. Obviously, your mobile phone can support the HTTP protocol. It can also, most modern browsers can also support the WebSocket mode. Okay, so if you have a device that can support HTTP and WebSocket, it can also fully connect to your router. Then your router will actually connect to your device, your smart device, via HTTP and also web service as well. Okay, so this is where there's no need for any protocol exchange because all the devices are fully capable of supporting both HTTP as well as WebSocket. Now, WebSocket is very similar to HTTP. It's just an enhancement that's supported on the modern browsers and more modern implementations of this web stack. So most of the modern browsers like Chrome, Firefox, they actually already implement this. So in a nutshell, typically in the classical IoT project, developers have to face a very challenging situation. They have to understand many different protocols. The technology landscape consists of diverse physical systems, services from different vendors and manufacturers. And to this diversity includes many different communication protocols, data formats, right, for exchange of data in the payload, and also many different security requirements. So you can see some of the multitude of acronyms that we've come across, and some that you have not seen yet because they are perhaps not so common or not standardized, so I did not actually include them in this set of slides, but you can find them in some environments. So you can see there's a very long list of them. Okay, so we hope to actually replace all these many separate kingdoms with one new protocol, which is the web protocol that sort of rules over all of them. It's very difficult to maintain. IoT applications in this kind of environment are going to be developed with much effort because you need to create many different implementations to support the different protocols. And during the lifetime, the cost of maintaining is going to be very high, right? Because you need to be, when something needs to be fixed, you need to fix it maybe for the version that uses MQTT, and then you need to also fix the one that also uses HTTP, and then you also need to fix the one that maybe uses some other one like AMQP. So with the Web of Things in a nutshell, it provides a standardized building block that just helps to simplify this application development. One single protocol, which is the web protocol, to connect everything together. One protocol to rule them all. So there are some basic concepts in the WOT implementation or Web of Things implementation. So the first thing that it implements is this notion that all your interactions can be thought of in terms of properties, actions, and events. Okay, all the interactions can be thought of, all your interactions or how you interact with a particular device or application can be thought of in terms of properties, events, and actions. So any IoT network interface can be described in terms of this abstraction. By using this abstraction, applications have a common way of retrieving this or accessing or interacting with the IoT device. Now think of the World Wide Web. There's only one common interaction idea for World Wide Web. We put in the URL or the address in your browser, and then it retrieves you the corresponding information. And for the HTML that's retrieved, all the URLs that are contained within hyperlinks, you click on it, you will then do a fetch for those things that are within the hyperlink. So that URL, the universal resource locator, that's actually the common abstraction that's used in the World Wide Web. But in the Web of Things, because it is more than just fetching, it's more than just request response, it's not more than just fetching information that we need to support. Therefore, we try to make it a little bit more generic, right? So we, instead of just the URL, we also have these three notions. So first of all is the property. What are some of the data that's associated with the device? If it's a sensor, it could be just the values that we can read from the sensor. There may be also properties that's related to the configuration setting. Is it set to only Fahrenheit, or is it only set to only retrieve data as Kelvins, or retrieve data as Celsius, right? So the configuration that you want to set for that particular sensor device. So some are actually are the information, but some of it could be the properties you associated with it. Okay, so computation results, the values that you read back from it. So the other thing is what can you interact with it? So in the World Wide Web, actually there are only four major interactions. First one is to get some data, then to post some data, which is to upload some data. Then there's the put, which is to actually update, insert some new data, and then the last one is actually delete, right, which is to remove a data. So you do find that actually for the these four actions are good enough for the World Wide Web, but it may not be comprehensive enough to take care of all the different situations in a Web of Things environment. So on top of that, we do allow for other custom actions, not just the put, push, post, get, post, put, and delete. So there may be other additional actions. And events actually for information flow from the other direction. So let's say I want to have notifications of something coming in from the application itself, or events that or information for alarms, right? So we do not want to wait for a request from the user. Is there a fire alarm going off or not? We just want to send the fire alarm if there's a fire, right? So this kind of notification of events where it's not based on a request for the information, but it's just sent one way from the sensor, are what we call events. So we need to support this additional notion. It doesn't require a request response kind of interaction. So the other thing is basically we need to have some sort of metadata to just describe what is actually in the resource, right? So in the Web of Things, there's this metadata called the Web of Things description. So it describes all the different properties that's associated with the object, all the actions that the object can take, and also all the events that are associated with the object. How the data is actually encoded, the TD is actually basically JSON LD, which I mentioned earlier in the earlier video, is linked data. So because in the World Wide Web environment, information may not be just stored in one single document. It may actually be that network of linked data that we want to actually access. So to support that notion, and it has been used very successfully in the form of URLs, right, for the World Wide Web. In the Web of Things description, we also support this as well. But we use JSON rather than HTML to encode this information. So it's more easily passed by a machine. HTML is wonderful for humans to take a look at, but it's really quite unnecessarily wordy for machines to actually interpret and use. Then we have what we call a binding template. So in general, the WOT tries to be protocol agnostic, so you can actually implement it over other mechanisms such as MQTT instead of HTTP. But most of the common applications will be actually expected to be HTTP because it's the Web of Things, right? So the default protocol for the web is HTTP with web service, web sockets. So MQTT is possible. So is CoAP or even other protocols. So as I said, they try to be agnostic or not only work on one single platform only. So it doesn't care. So it can work on multiple platforms. So we try to take over, we try to define it in such a way that it can work over multiple protocols by making use of this mechanism called the WOT binding template. So the binding template is actually a guideline for how a protocol like HTTP or MQTT will be used to support the interaction, the property, action, and events that we are having for that particular device, right? So for example, if you have an action call get associated, like get a particular property, how does that get action get translated to a particular protocol message that you have? So in the HTTP case, get will probably just translate to the get action in the HTTP protocol, but there's may not be a corresponding one for MQTT. So you need to define that in the WOT binding template. So as I said, you can expect that most of the implementations will just try to ride on the practical implementation experience people have with HTTP and together with WebSocket. But the mechanism that's being defined does allow you to use other protocols instead. Okay, so finally, there's also this scripting API that allows you to use JavaScript to sort of script or program how you want to interact with a particular WOT device. So we know that actually JavaScript is the default programming language for browser applications. ECMAScript or JavaScript is sort of the universal programming interface for browsers. So we want to actually take advantage of this experience with JavaScript and ECMAScript with web browsers to also support the same application development with web applications, with WOT as well, Web of Things. This scripting API would actually solve a big problem with the heterogeneity of IoT systems. Well, currently, IoT systems do not have like a common API or programming framework that we can use with them. So with this scripting, that would actually provide a common scripting method. There may be other languages also supported, but at least as a base, we have the WOT scripting API. And lastly, security is not left out hanging. So there is actually a guideline for implementing security in the different aspects. So actually, Web of Things, all the different components, right? The TD, the binding template, as well as the interactions, they are susceptible to hacks or attacks. So there's a defined way of actually handling each of the different security concerns. Okay, it's called the WOT Security and Privacy Guidelines. Especially with the scripting API, any programming language that can be remotely accessible is always scary, right? From a security point of view. So here, let's talk about some implementations or references, implementations that's out there for the Web of Things. So Web Things is actually the Mozilla project, which is an open source project from the Mozilla group to actually implement the Web of Things as defined by W3C. So originally, the Mozilla Web Things is actually hosted at the Mozilla site, okay, under iot.mozilla.org. But they have actually moved it on to another URL. Okay, so there's actually a link there. So the Web Things is the Mozilla open source implementation of the Web of Things. And it also includes two things. One is actually a Web of Things gateway. So we can also have a gateway to collect information from more simpler devices so that we can then present a single Web of Things interface to the cloud. So as far as the applications on the cloud is concerned, all your devices are WOT capable, even though they may be simpler and running maybe MQTT protocol or even simpler CoAP. And then also a framework, which is a programming framework, how this is actually working. So now this is a new site, actually the webthings.io website. So this is the same project, but it's just that they have now got their own identity, their own branding that is separate from the Mozilla. So this is actually a fork off from the Mozilla project. And the API that they talked about, the WebThing API, is basically that framework. So you can actually look at this URL resource, and you point you here where the framework information is available. So the Web of Things framework is a collection of reusable components to help you build your own Web of Things implementation. So you don't have to reinvent the wheel. So some of the libraries are already provided for you. And this means that they can be discovered by a Web of Things gateway and then automatically detect the device capability. Because remember, this is the reference implementation. So how does the concept of TD, the description, right? The thing's description get translated into a real programming interface. And how is it discovered? And how do we discover all the different properties? So this reference implementation makes real what was actually just in the specification, which is a big step forward. So it's not just a paper specification, but there's a reference implementation behind it that you can use and adopt. And things like the web protocol, those are just the built-in ones that's already been supported by the whole operating system platform, or be it on the IoT and on the IoT device or on the client side. So this is just the first page of the WebThings API. So you can see that it's a data model, etc., programming interface. Some of the common things like the WebSocket interface is already part and parcel of what is already used in the browser. It's just that now we are reusing this experience in the context of the Internet of Things, or in this case, the Web of Things. And it references the W3C Web of Things standard. So this document describes the common data model and API for the Web of Things. The Web of Things description is actually a part of the W3C, or World Wide Web Consortium's standard or specification. So with that, we actually come to the end of this topic on the connectivity and the protocols that are used for IoT, and also the ones that will be potentially used for the artificial intelligence of things as well. So I try to cover some of the more stringent requirements that we would actually need for AIoT, especially for latency, because when we are trying to do automated control, latency would be a problem for this application. So when latency actually or delays tends to cause instabilities in the control network. So the other thing that I also try to introduce is this idea that we can reuse some of the experience that we have on the web, such as the Web of Things and also XMPP, because the practical implementations is actually a big step forward when we try to scale up to much billions of objects that we will actually potentially see on the in the artificial intelligence of things, and even in the IoT of the future. And this is also one of the problems that we are currently encountering, because the present state of things is that there are many IoT protocols, or what we call IoT protocol fragmentation. So hopefully having that one single protocol to rule them out will already rule over the whole AIoT network will actually help to try to address some of these problems that we have with the IoT protocol fragmentation. And with that, thank you for your attention, and I will see you in the next module.